Hello dear students, welcome back to NEET World. So in this session we will be discussing amines. Okay, this is our part 2 on this amines chapter, right? Yeah, so let's begin our discussion on this amines. Okay, so in the last session I have clearly explained, I have clearly discussed the EAPCET nomenclature as well as a preparation method, different preparation methods that must be focused for your exam point of view for JEE, NEET and EAPCET exams, right? Yeah, we have clearly discussed them and we solved few questions also related to those concepts, right? So in this class I will be explaining some chemical properties, the chemical reactions that amines undergoing. Okay, and after that we will be solving PYQs. Okay, first we will be focusing on chemical properties. Once after completing the discussion, yeah, we will be looking into some questions, and once after completing full chapter, again we will take only PYQs and we will do that. Okay, right. So these are the things we are going to do now. Okay, right. So in the last session, yeah, we have covered the EAPCET nomenclature by using these things and preparation methods. All these preparation methods were used in the last class, right? So all these were discussed, right? Right. Now in this class I will be taking the basic nature also discussed. What I told you, basic nature of amines is explained based on their conjugate acid stability. Okay, if conjugate acid is more stable, then that is more basic, I can say. Okay, now I told you I have given the order in aqueous medium, okay, in the aqueous medium as well as in gaseous state, okay, in the vapor phase. So in the aqueous medium, what is the order we have considered? For methyl group containing like R, NH2, this is primary amine. Like that we have secondary and we can also have tertiary, right now. So if this R group is, if these R groups are methyl groups, then what I told you, if it is methyl group, then I told you that 2, 1, 3. So secondary amine is more basic, then followed by primary, then least is tertiary. Okay, so if R group is other than methyl, then the order will be 2, 3, 1. Okay, this is what we have discussed in the last class. Then I explained aromatic amines and their basic nature, right? So based on that, look at this question. Yeah, so the question says arrange the given species in the increasing order of their basicity. Yes, can you try this question now? Can you answer me this based on your understanding from the last class? If you haven't watched, anyways I will explain here. Just try this. Just try from your side. If you are unable to answer, I will give you explanation, clear explanation I will be giving you, but you just try me, give me your answer. Yeah, see now we know amines are basic due to presence of this NH2 group. Okay, because the lone pair electrons present on this nitrogen will accept the proton. So proton acceptors are considered to be bases. So amines are basic. Okay, right. Now if the ability to accept the H plus ion is easy, then we can say that is more basic. Okay, now this nitrogen lone pair should easily accept this proton. That is what the basic nature I can say. Now if you see, all of them are having anilines only here, but here we have methoxy group, here nitro group. What this nitro group will do, it's an electron withdrawing group now, so it will drag the lone pair electrons of nitrogen of this aniline towards itself. Okay, so it is electron withdrawing group. But here you have electron releasing group. It is donating electrons, its electron into the system, and that will increases electron density on nitrogen atom of this aniline, so that it will easily accept the proton. So it means whenever there is electron releasing group, the basic nature of amines increases. So from 1 and 2, which is more basic here, 1 is more basic because it has a releasing group here. Okay, therefore it increases electron density, and now lone pair electrons are freely available to accept the proton in case of this first compound. Okay, so one is more basic. And here if you see, there is no such groups, no electron releasing group, no electron withdrawing group. So what I told you, whenever there is a withdrawing group, it will withdraw electrons towards itself. Therefore the nitrogen lone pairs here are less available to accept the proton. So it should be least basic. Okay, so second one should be least basic. Now in between we have these two things. Okay, so here Chlorine is weakly ring deactivating group due to its minus I nature, okay, but it is a strong ring deactivating group. Therefore, here 2 followed by 3 and here 4 and 1. Okay, so this is your final answer for the basic nature of amines. Okay, I hope the discussion is clear. Right, if this is clear, just hit on the like button. Yeah, just click on the like button if this discussion is clear means. Right, let me give you one more question. Yeah, tell me the basic nature order for the given compounds. Basic nature order for this second question. Okay, so X, Y, Z are the 3 compounds they have mentioned. Now which is more basic they are asking. Now if you observe in the last class also I have explained about steric inhibition of protonation. Means what? Whenever a methyl group is present or whenever a group is present at the ortho position of this nitrogen like aniline. So on these anilines or derivatives of anilines, if any group is present at this ortho sites, okay, at this position, at second position, whether it can be releasing group or withdrawing group, irrespective of the electron releasing or electron withdrawing group attached, okay, that decreases the basic nature of aniline. Okay, why it is decreasing? It will hinder the protonation. Okay, it will hinder the protonation at this nitrogen site. So that's why it is least basic. Okay, so now tell me, here we have electron releasing group but no use. What I told you, at the ortho position any group whether it can be releasing or withdrawing group are present, that decreases the basic nature because they hinders or they will inhibit the protonation of this NH2 group. That's why which is least basic, which is least basic here, X is least basic. Now here you can see para position methyl group is there. Yes, it will activate the ring by releasing the electron and there is no such group. So Y is more basic and in between X and least is in between Z and least is X. Okay, this could be your final order of basic nature for the given compounds. Okay, then next. Okay, next one here is acylation. So what do we mean by acylation? So adding of this acyl group like CH3 CO group is added onto the nitrogen containing compounds. For example, here you can see aliphatic and aromatic primary secondary amines react with the acyl chlorides or acid anhydrides and esters by nucleophilic substitution reaction to form amides. So it's very easy. See what I am taking here, acyl halide, let us say this is something like acyl halide you can say. Okay, so now halide ion X, let us consider X is a halide ion or a good living group here. Now what happens, we are reacting this with primary amines. Okay, let us say this is a primary amine. Now what happens is, like nitrogen lone pairs are there, they will attack on this electrophilic carbon here like this. Okay, so it will be, I will tell you the simple tricky way also, but just follow this mechanism what is happening. See R, C, this double bond will become single bond O minus. Okay, X is there here and this NH2 group is attaching NHR. Okay, right. Next what happens is the negative charge oxygen giving back so that like halide ion goes out. So what is happening here, you are removing this hydrogen and this halide ion as HX and forms R, C double bond O, NHR. Okay, so what is this compound called now? It is an amide. What is the product formed? Amide. See, N-alkyl amide is a product formed here. Okay, so it can be now anything like acid halide or acid anhydride or even ester, that will be giving you amides as your final products. That's it. So this is what acylation means. On the nitrogen we are adding this group now, this group is called acylation group. Okay, this is called acylation. So acylation of amines gives you amides. What they will give? Amides. That's it. Okay, so now this reaction is carried out in presence of base. Generally pyridine is considered. So what is the base here? We can take a pyridine. Okay, so what is the use of this base? Yes, that base will abstract this proton from nitrogen. Okay, therefore it makes the reaction to be faster. Okay, that's it. Right, let's move forward. So the tricky way here you need to remember is directly you can write, no need of writing all these mechanistic steps. Yeah. See, just remove this hx. What is the remaining part we have? R C O N H R. Okay, that's it. This is what the product formed here. This is what the final product formed here. So you are removing HX, so NHR. This is what? The same as the thing we have written here. So N-alkyl amide is your final product. Okay, that's it. Next, reaction with aldehydes. See, aldehydes and ketones react with primary amines in the presence of acid as a catalyst to form azomethines, or we can call them as imines, okay, which is also called as Schiff's base. Okay, I will tell you, just to see. This is a ketone or aldehyde, you can say carbonyl compound. We are treating this with amines. Okay, let us say this is a primary amine. So just remove this water molecule from here like this. Okay, this process takes place in acidic medium. So now what happens between the carbon of this carbonyl group and this nitrogen, double bond formation is taking place like this. Okay, so see, carbon and nitrogen double bond is there now, you should call this as imine. Okay, what is it? It is imines. Okay, and we can also call them as Schiff's bases. What is this? Schiff's bases. These are important fragments in the chemical synthesis. Schiff's base. Okay, right. So once again, aldehydes or ketones reacting with amines gives you Schiff's base, like imine formation, that is also called as Schiff's base. Okay, remember this. Okay, right. Now I will be giving you one more thing which is more basic here. Tell me, amines or imines? CH2 NH2. This is amine, and here CH double bond NH R. So out of these two, tell me which is more basic. Both nitrogen have lone pairs, but which is more basic out of these two? See, this nitrogen is sp3 hybridized, this nitrogen is sp2 hybridized. Okay, if see here, just what is the percentage of S character? 25, but here it is 33% because it is sp2 now. So now what you can say, more is the percentage of S character, more is the electronegativity. If the species having more electronegativity, the lone pair electrons are strongly held by that atom. Okay, it won't give the electrons easily, therefore it is will not accept, or it will not have tendency to accept H plus ion like this nitrogen, because it is sp3. So because it is less electronegative, easily donates its lone pair to the proton. So I can say amines are more basic than imines. Remember this, what I am saying, amines are more basic than imines. Okay, this is also important point to be remembered. Right, let's move forward. So the next one is Cope elimination. So just tell me what is Cope elimination. Yeah, before going to this, I will be giving you one more question. You just tell me, because you can expect direct questions of amines based on their basic nature. Okay, right. Here I am writing. Yesterday's class I have given this question as a homework. Okay, and the next one here is so let me change the position of this. So write the basic nature of this A, B, C, 3 compounds. What is the basic nature order for these 3 compounds? Tell me. Anyone in the comment box, please mention your answer. Yes, anyone please? You can try, even if it is wrong, no issues, I am going to explain now. So now look at this, basic nature means again it is tendency to donate the proton electrons to the proton, right? Yeah, here it is sp3 directly. Yeah, this nitrogen is also sp3 but attached to an sp2 hybridized carbon, so which is minus I effect it is showing. So it is easily donates. So A, after that B, and least is C. Why least is C? Because the lone pair electrons here are not freely sitting on the nitrogen, they are in conjugation. So due to the conjugation they are less available to accept the proton, so it is least basic. So A, B, C will be the basic nature order from the given 3 compounds. Okay, right. Let's move forward to the cope elimination. Right, cope elimination means you can see tertiary amine oxides having beta hydrogen. Okay, let us say there is a nitrogen here. There is one nitrogen like this. Okay, so this is a tertiary nitrogen. Okay, now we are adding something like peroxy bond here, some peroxide R2O2 is given. So now what happens, it will provides oxygen atom. So that oxygen atom is taken by the nitrogen here and making it to be amine oxide. So this bond, like this compound whatever you are seeing now, is considered to be amine oxide. So we can write this dative bond, or simply you can write it as O minus N place. This is also proper way of indication. So you can say tertiary amine oxides. How tertiary amine oxides are formed? When you treat tertiary amines with peroxides, you are going to get your tertiary amine oxide. Now tertiary amine oxide, see, we have, this is alpha carbon, this is beta carbon. So this is also alpha, this is beta carbon. So at least one proton should be there at this beta carbons. Yeah, we have one proton or two protons here, but minimum of having one beta hydrogen. Okay, so now this what happens upon heating, so this beta proton is eliminated and this group will shift this side. Okay, so it will forms an alkene now. What it will forms? It will forms an alkene now. See, this bond is getting disconnected here, right? So like this, nitrogen and methyl group. Okay, so this will be now O minus. Okay, see now what we are removing from here, proton now, so that proton is taken by this OH, like O minus, so it becomes OH here. Okay, and here it is forming a double bond. That's it, this is your product, because this bond is cleaving now. Yeah, cleavage takes place and it will be CH2 unit. Okay, now again you can make the reaction forward. Okay, so this is your final product as of now. See, what is the product formed? Alkene is formed. Yes, alkene is formed. So this follows Hofmann elimination product. It means what exactly Hofmann elimination means, I will tell you. See, look at this, the same possibility is there from this side also. Okay, now I am making it unsymmetrical amine oxide, like, or let us say methyl group only, CH3, but here I am making one alkyl group, so amine oxide. So tell me now what happens? Same you are heating it. Now from which side bond breakage takes place? Either this beta proton or this beta proton. Always remember, you are going to get a less substituted alkene. We know Sage-Jef product means more substituted alkene. More substituted alkene is major product because it is more stable. But in case of this cope elimination, you are going to get a Hofmann product, that is less substituted alkene. It means this side only cleaving takes place, like elimination takes place. Okay, right. I will be giving you one more example so that you will feel more clear on this discussion. Okay, let me explain one more. Yeah, this is also tertiary amine oxide only now, the same compound I have taken here. Okay, now tell me, I am saying you to heat this. Now what happens and where it happens? See, here this is a bigger chains, now bigger alkyl chain. So now what happens is, what are the beta carbons we have with respect to this nitrogen? This is alpha, alpha, alpha. Okay, alpha, alpha, alpha. This is beta, this is also beta, this is also beta. So now tell me which is give least substituted alkene. Okay, so I can eliminate this beta proton easily instead of removing from here. So because here less substituted alkenes, Hoffman product is formed in cope elimination. So that beta proton is removed from here, like out of these three, one proton is removed and you are going to get OH like this place CH2 double bond CH2. So this is the alkene formed as your major product. Okay, I hope you got what I am explaining in the cope elimination. Okay, right, let's move forward. Yeah, look at this, what they are saying. Reduction of nitro compounds. See, reduction of nitro compounds using this. For example, like RNO2 is there, otherwise nitrobenzene is there like this. Okay, so upon treating this with vapors, like vapor phase reduction using reducing agents like copper oxide, okay, on silica SiO2, okay, or vanadium or platinum catalyst we can use. So now what happens, we are going to get amines. Okay, so we are going to get amines like RNH2, or if I say this one nitrobenzene, you are going to get NH2, aniline you are going to get, that's it. Okay, this is what you can say. Okay, catalytic hydrogenation, that is also hydrogenation means addition of hydrogen only, no? Yeah, so you can do this same process, same product will be formation takes place when you treat this with H2 PD. Okay, so here like carbon is PDC you can take, and ethyl alcohol. Okay, so that's it. So this is also going to give you aniline as a product. Okay, so that's it. These are the two things you can remember for reduction, conversion, product. Okay, next process is conversion of phenol to ammonia. So how can we convert phenol to ammonia? Yeah, so you can do this using phenol plus ammonia plus zinc chloride here. So what is the catalyst I am using? Zinc chloride at 300 Kelvin, 300 degrees Celsius. Okay, you are going to get aniline. Okay, phenol is giving you aniline. Okay, this is also an important conversion to be remembered. Okay, right. Next, reducing azo compound, reducing of azo compound. See, what do we mean by azo compound? See, here we have N double bond now, so that is called azo bond. Okay, that is upon reduction with nickel hydrogenation, metal catalyst hydrogenation. So at 315 Kelvin and 15 atm, you are going to get a compound with a single bond, like N single bond. Reduction is taking place. Okay, now if you treat this compound with HCl, we are going to get a diphenyl like aniline with a condensed form. Okay, and here you are going to get aniline, direct aniline product when you are treating again this with nickel hydrogenation. Okay, it's same conditions. Okay, that's it. Okay, different products. See, these conditions to be remembered now. What makes the difference is important here. Okay, the next one, reduction of aromatic amines. So if you see aniline treated with Na2Cr2O7, is a strong oxidizing agent in presence of sulfuric acid, we are going to get a quinone, benzoquinone as your final product. Oxidation of aromatic amines are readily oxidized to various products depending upon the condition. So here what is the condition mentioned? Na2Cr2O7 and using sulfuric acid. You are going to get a benzoquinone, which is a brown color compound. Okay, so now halogenation. So halogenation of aniline is also important topic to be mentioned here. So aniline, if you treat this with bromine water, Br2H2O, bromine water, we are going to get a tribromoaniline. Okay, 135, all ortho positions and para position get brominated like this. Okay, because aniline is highly activating the activated ring by this nitrogen lone pair. That's why bromination takes place at ortho and para position. Okay, remember this. Okay, right. Now what if we want to do only bromination at para position and all? So it's very easy. First of all, if I want to get a para product as a major, you just decrease the activeness of this NH2 group. For that purpose, I am doing acylation of that nitrogen of aniline. Okay, so I am adding this, okay, in presence of like chloride, okay, halides you can take, in presence of something like anhydrous AlCl3. Okay, now what happens first? We are going to get acetonylides, okay, NHCOR. So this is what formed first. Okay, see, if you see, it is activating the ring more effectively. Here also it is activating the ring, but not effectively as we seen here, because the lone pair electrons here are involving the conjugation with the ring electrons and also in conjugation with this pi bond of this carbonyl group right now. So due to this electron withdrawing group, the activeness of this nitrogen is getting reduced, okay, decreased. Okay, therefore if I do bromination, that bromine will goes only as meta position, okay, at meta position as major, COR and Br. Okay, up to here it is clear now. So you just do acid hydrolysis. So now what happens, this cleavage takes place to give you, or you can treat with base also, NH2. Okay, that's it, and bromine here, that's it. So we got our para bromo product as a major. Okay, I hope you got clarity that if you want to do polybromination, you can directly add bromine water to the aniline to get this kind of product. But selectively do bromination at para position is possible by deactivating the nitrogen, like aniline's nitrogen, that's it. Okay, so the now next one is nitration. So if you observe nitration, this is one of the important frequently asked question mark. So aniline, upon treating with nitric acid and sulfuric acid, it generates a nitronium ion. Okay, what is the electrophile here? Nitronium ion. It's very simple. Ma. See, aniline, nitration of aniline will be giving you nitroaniline. Like at one of the position, nitro group should be added because it is a electrophile. So now electrophile generally goes to para positions and ortho position. This point we know. So that's why we are going to get a para product as well as ortho product. This is what we consider most of the cases. But along with this, what you need to think about is aniline is a basic compound and nitric acid is an acidic group, like acidic acid right now. It's an acid. So it releases H plus ion. So whenever nitric acid is releasing H plus ion or sulfuric acid also taken. So from things S plus ion is releasing now, that is taken by this nitrogen of aniline. So it will become now NH3 plus. So now it is becoming an electron withdrawing group. Whenever electron withdrawing group is present, the electrophile goes to meta position. So now whenever we have NH3 like this, so now nitronium ion, whatever the electrophile is there, that goes to this meta position. So you can also get a meta product here. Okay. Now if you look at the ratios or the percentage of ortho para meta product formed, so it will be really interesting. See, the para product formed here is 51%. How much it is? 51%. And ortho product is just 2%. What is the percentage of ortho? 2%. But meta product is 47%. So which is major? First one is para major, the next meta, and next least is ortho. So just remember it as PMO. Okay. So nitration of aniline gives you the major product as P, the next M, the next O. PMO you can remember. Okay. So this is a simple way to remember the percentages of products formed. Okay. Right. Let's discuss few more things. Yeah, let me give you one more. Yeah. So here again, when it comes to aniline, the diazonium chloride reactions are very important. See, what do we mean by diazonium chloride? treat aniline with NaNO2 HCl, okay, at 0 to 5 degrees Celsius. Okay, now what happens is this nitrogen will be making a diazonium like N triple bond N, this kind of compound like N plus. Okay, it's a salt, cation and anion, so it's a diazonium chloride salt is formed, and it is unstable. What I am saying, it is an unstable species. Now upon heating it, what happens, N2 gas comes out. Okay, that's why it is unstable. Now there are some applications, there are uses of this diazonium chloride in organic chemical synthesis. Okay, so now you can treat these with just CuCl, okay, and HCl. Now what happens, you are going to get a chlorobenzene, okay, and you can also prepare bromobenzene and you can prepare cyanobenzene. So that reactions are called Sandmeyer reactions. What is the reactions called? Sandmeyer reactions. And now you can treat this with Ki. Okay, if you treat this with Ki, you are going to get iodobenzene. Okay, next you can treat this with HbF4. Okay, you can call it as a Ball-Schieman's reaction. So fluorobenzene is a product. Okay, fluorobenzene is your product formed. Okay, these are some important reactions to be remembered. Now there are some coupling reactions with this. Let us discuss those things also. Yeah, so these are all important reactions of diazonium salt to be remembered. Okay, just see one by one we will discuss. If you, to the diazonium chloride, if you add water, you are going to get phenol by elimination of N2 gas. Okay, in all these reactions, whatever we are discussing now, all these reactions follows aromatic, see N2 minus is going out, nucleophilic, aromatic, nucleophilic substitution reaction is taking place. What is taking place? See, this N2 is going out by taking the sigma bond from the carbon of this phenyl right now. So it is going like a nucleophile creating a positive charge on benzene ring. So the phenyl ring, there this H2O is attacking, it means it's a nucleophile. So one nucleophile is going out, another nucleophile is coming in. So you can say it is an aromatic nucleophilic substitution reactions. Okay, in all this reaction, that will be the mechanism followed. So you can see benzene diazonium chloride with water, you are going to get a phenol. Benzene diazonium chloride with H3PO2, with what? H3PO2, we are going to get benzene. Okay, and with benzene diazonium chloride, if you take CuCl, you are going to get a chlorobenzene, that is called Sandmeyer reaction. With bromine, CuBr, bromobenzene is formed. Okay, with Ki we are going to get potassium iodide. With HbF4 we are going to get fluorobenzene, that is what Ball-Schieman's reactions I told you. Okay, and we can also use some fluorinating agents like arsenic hexafluoride, you are going to get a fluorobenzene. Okay, then next with KCN you are going to get a cyanobenzene. Okay, with ZnHCl, what happens here? Yes, this reaction again important. ZnHCl excess quantity, so it will undergo reduction to give aniline. Okay, so diazonium chloride converted into aniline when you are treating with zinc and acid. Okay, like HCl. Okay, then next one, diazonium chloride with CuBr. Okay, CuHBr, you are going to get bromobenzene again. Okay, so this is called Gutterman reaction. What is that reaction called? Gutterman reaction. Okay, then next, and diazonium chloride with copper powder. So coupling reaction takes place and gives you biphenyls or diphenyls. Okay, now diazonium chloride with phenol in basic medium. So this is one of the important reactions. These last two reactions are important. So diazonium chloride with a phenol in basic medium, we are going to get a azodize, like dye, orange color dye is formed here. You can see OH. Okay, so at the para position of this phenol reaction, like this nitrogen will be attached. Okay, we are going to get a compound like this, then orange color dye. Okay, same diazonium chloride with aniline in acidic medium. With phenol it should be basic medium, with aniline it should be acidic medium. Okay, we are going to get a yellow color dye like this. Okay, so this is a thing to be remembered here. Okay, all these reactions, try to take a screenshot of this. It will be really helpful for revision purpose. All reactions of diazonium chloride are covered here itself. Okay, let me zoom it out if you are unable to take it. Yeah, yes, so just take the screenshot of it, it will be really helpful. Yeah, the next one here, test. There are some tests that will be shown by the amines. Okay, so to identify amines, like for example we have primary, secondary, tertiary amine. No? So how can we identify primary, secondary, tertiary amine? Yeah, we can do that using Hinsberg test. Okay, and what is Hinsberg reagent? Benzene sulfonyl chloride. Okay, benzene sulfonyl chloride, like so double bond O Cl. So this benzene sulfonyl chloride is called Hinsberg reagent. Okay, so this benzene sulfonyl chloride, upon treating with primary amines like RNH2, we are going to get a substitution reaction here in the place of chlorine, and that gives you NHR. Okay, now this compound, upon adding to KOH, it will form a dissolve, like it will be dissolved in the KOH, alkali medium. So now what I am saying, primary amines, upon treating with benzene sulfonyl chloride, reaction takes place and the product formed will dissolve in the basic medium like KOH, because there is an acidic proton here that can be abstracted by this base and forms respective salt, like benzene diazonium chloride here. Chloride is removed now, so we are going to get N minus R K plus. So this salt, which is a soluble salt, a dissolved salt in the KOH alkali medium. Okay, now if you do the same reaction with the secondary amines like NRRH, okay, remove this H and this Cl, we are going to get S double bond O N R and R. So we are going to get this product, but it will not be soluble in KOH. It will not be soluble in KOH. Okay. Now the same compound, if you treat with the tertiary amines, there is no reaction. See, primary amine is undergoing reaction and dissolving alkali medium, whereas secondary amine undergoing reaction but not dissolving in alkali medium, and tertiary amine there is no reaction at all. So it means by looking at these reaction steps, we can identify or we can distinguish primary, secondary, tertiary amine. So this is how Hinsberg reagent is helpful for the identification of primary, secondary, tertiary amines. Okay, right? Is this clear? Is this clear, whatever we discussed? Yeah. So next one is with nitrous acid test. What is that? Next one is with nitrous acid test. Okay. So just take the screenshot of this first Hinsberg reagent test. Yeah. So when it comes to nitrous acid test, you can just take primary amine like RCH2NH2. Let us say this is primary amine. Upon treating with nitrous acid like HNO2, so you just remove N as a N2 gas and we are going to get alcohol as a product, or CH2OH. This is the product formed in case of primary amines. Okay, and in case of secondary amines, we are going to get RCH2NRH plus HNO2 we are doing now. So this will be giving you RCH2NROH. Okay, ONOH. Okay, 1 minute. N double bond O. So it's very simple. You just write HNO2 means like this now. O, okay, and OH. Okay, that's it. Okay, so now you are removing water like this. After removing, what is the thing we have? A bond is making between nitrogen, that's it. So we got that thing here. So this is a product formed when it is a secondary amine. When it is a secondary amine, this is primary, this is secondary. Like this, depending upon the product formed, we can identify different amines. Okay, right. So this is an yellow oily liquid formed here. What is this? This is an yellow oily liquid. Yellow oily liquid formed. Okay, so when it comes to tertiary amine, so it will form an unstable product. Okay, so by looking at these reactions, we can identify primary, secondary amine. And when it comes to carbyl amine, this is one of the very, very important reactions, carbyl amine test. So what is this carbyl amine test? Like you take primary amines, okay, treat this with chloroform in basic medium. Okay, we are going to get alkyl isocyanate. Yeah, every time you can see question either from Hinsberg reagent or from carbyl amine test when it comes to the practical approach or the practical chemistry of amines. Okay, so either Hinsberg reagent or carbyl amine test is important thing to be focused here. See, only primary amines will give you carbyl amine test. So primary amines, whether it can be aliphatic, aromatic, upon treating with chloroform in basic medium, we are going to get alkyl isocyanates. Okay, so they have very bad smell, like foul smell. So foul smell indicates alkyl isocyanates are formed in the reaction. Okay, so with this reaction we can get to know whether a given amine is primary or not. Okay, right. Now they will give you 4 compounds like this. Which of them is giving carbyl amine test? One is aniline is given, and one methylamine is given, and like this one more compound is given, and 1, 2, 3, like this they will give you 4 compounds, and 4th one let us write CH3CH N H CH3. Like this they will give 4 compounds. Tell me, out of these 4, which of them gives carbyl amine test? Tell me, based on your understanding. I told you one simple single line statement. Only primary amines will give you carbyl amine test, right? So primary amines only will give you carbyl amine test. So what will be your answer? So 1A, 1, 2, 3 will give you the like carbyl amine test in the given 4 compounds, right? Yeah, so that's it. So now let's see some only what are the things here. We have primary amine here, and here also primary amine, and this is also primary amine. That's it. These are the 3 things will be giving you carbyl amine test. Okay, next one, just answer me this. Final product in the following reaction sequence. Now based on our discussion, you can easily answer me this. See, primary amine treated with HNO2. This is HNO2, nitrous acid. What happens primary amines with nitrous acid? Just now we discussed. It will be giving you alcohol here. So ethyl alcohol will be formed, CH3, CH2OH. This is X. Okay, treated with thionyl chloride, SOCl2. So one chlorine will substitute in the place of OH to get CH3, CH2, Cl. Okay, this is Y. Okay, so Y treated with ammonia. Treated with ammonia. Again, what happens? The same product will be formed now. Yes. So treated with ammonia, what happens? Ammonia, if you add here, chlorine goes out. You are going to get CH3, CH2, NH2. So 1, 2, 3. So ethanamine is formed, like ethanamine. See, 1, 2 carbons are there, 1 nitrogen. So ethanamine is your answer for the question. Okay. Hope the discussion is clear. Right. Let me give you few more questions. Few more questions from here. So out of this discussion, yesterday's Gabriel thalamide synthesis is one of the important question to be remembered, because from Gabriel thalamide synthesis, let me make a question here. Yes. So D. Now they will say D gives you carbyl amine test, or they will say E is formed when it is treated with CHCl3, chloroform and KOH. Okay. Now what is the products here from A to E? What are the products formed here? See, it's very simple. See, upon heating what happens, this 1,2 dicarboxylic acid is there now. From there water elimination takes place like this. Okay, we are going to get an anhydride. Yeah, this is the anhydride form. Upon treating with ammonia under heating condition, now what happens? Hydrogens and this oxygen removed as water to give you thalamide. Okay, so this is your B. So B is treated with KOH. So this acidic proton is abstracted by this OH minus, gives you potassium thalamide here. N minus K plus. So this potassium thalamide here act as a nucleophile. So this chloride ion will be going out and substitution reaction is taking place and gives you CH2 CH3. Okay, this is your D. So D upon treating with chloroform. Okay, what we got D now. So D has to be hydrolyzed here. So D has to be hydrolyzed. Okay, now what happens upon hydrolysis? Bond breakage takes place and gives you E. So E can be now, can write as like this. So this is separated and we are going to get CH2 CH3 NH2. Okay, because you are breaking bond here now, so we will get hydrogen OH here, hydrogen OH here. Okay, so acidic like acid group dicarboxylic acid you remove out, you are going to get this as E, because E upon treating with chloroform and like KOH or NaOH, you are going to get a carbyl amine test, that will be F. So this one upon treating with chloroform and NaOH, carbyl amine test, yes, this is a primary amine now, you are going to get isocyanate. So CH3 CH2 CH3 CH2 N triple bond C, isocyanate is formed. Now we can add few more steps, because in the yesterday's class we have studied about reduction of amines, reduction of cyanides or nitriles or isocyanates, we have discussed now. So if is treated with lithium aluminium hydride, now what is the product formed? F is treated with lithium aluminium hydride. Now tell me, so I am treating this with F, this is F now, treated with lithium aluminium hydride. Now tell me what is the product formed? Yeah, so isocyanates gives you secondary amines, because this terminal nitrogen like carbon is there, that will be converted into methyl group. So CH3 CH2 N CH3 and here hydrogen. So this is a secondary amine formed as a product. Okay, like this we are going to make many like reaction series reactions, so that you get more practiced, I mean more confident about your learning process, because if you do one single reactions, you will be only having one reaction idea, but if you bring all together and make this reaction series, this kind of reaction series, then you will feel more confident about your preparation, because it includes multiple concepts, not a single one, right? So try to practice with this kind of reaction series questions, okay, that will boost your concept, okay. And right, so let's move forward with the PYQs, okay, right. So what I am going to do is, I am going to add PYQs. Let me give 1 minute. Yeah, so I am going to add PYQs in the upcoming session. So this is about amines chapter, like all the important topics were discussed from amines. Yeah, so whatever the important questions, the PYQs are there, not only from amines, from other chapters also. I am going to add all them together and we will be discussing them in the upcoming session, that is tomorrow's session, okay. So you just stay connected with our NEET World YouTube channel, okay. Tomorrow we are going to discuss all the important questions from amines and also from other miscellaneous concepts of organic chemistry, okay. So thanks for watching, stay connected with our NEET World channel. Thank you.